Well, hi there. I'm going to work on a few questions that come from the Math Olympics hosted by UNF from the 2019 multiple choice portion of the competition. So this is question number 1, which says solve for x, and we have the equation 9 to the x plus 3 equals 1 over 27 to the x squared minus 2. So I notice that we have an exponential equation because the variables are in the exponent, and the base on each side is a power of 3. So I'm going to use the technique of relating the bases or a one-to-one property of exponents to rewrite both sides of the equation with the same base. And once I write both sides of the equation with the same base, then I can equate the exponents and then solve the resulting equation. So I'm going to write 9 with a base of 3. 9 is 3 squared. And 27 is 3 cubed. And I can use some properties of exponents. I'm going to use the power rule and multiply the exponents together. That's 3 to the 2x plus 6. That power rule allows me to multiply these exponents together. And I'll do the same thing on this side with the power rule. 1 over 3 to the 3x squared minus 6. And I want to move this factor into the numerator, the property of exponents, with a property of negative exponents. So I'll have 3 to the 2x plus 6 equals 3 to the negative 3x squared plus 6. Now that I have the bases the same, the exponents must be equal to each other. So 2x plus 6 equals negative 3x squared plus 6. I'll subtract 6 on both sides. They cancel out. I have negative 3x squared equals 2x. I'll move that term to the other side and have 3x squared plus 2x equals 0. I can factor out an x, and that gives 3x plus 2 equals 0. I'll set each factor equal to 0. And that gives x equals 0 and x equals negative 2/3. So I would answer none of these. Question 2 says you have 3 fair 6-sided die. If you roll all 3 dice at once, what is the probability of rolling at least 2 ones? So rolling 3 6-sided die is an example of a binomial experiment. The experiment is repeated for a fixed number of times. That's for the 3 die. We use n for the number of trials. There's only 2 possible outcomes: a success. Success will be rolling a 1. A failure will be rolling any of the other numbers, 2, 3, 4, 5, or 6. The probability of a success is going to be the same for each trial or each die. So the probability that we roll a 1, we label that as P, is 1 out of 6, and that's the same for each die because each die is fair 6-sided die. And the random variable that we use is going to count the number of successes or the number of successful trials. So we could have all 3 die being some other number than 1, meaning that we have 0 successes. We could have 1 die, 2 die, or 3 die showing a 1. So these are the possible values of the random variable. So we want to calculate the probability of rolling at least 2 ones. So to calculate the probability of at least 2 ones, what we're doing is we're finding the probability of 2 or 3 ones. So to do that, we need the formula for calculating probability of a binomial experiment. So I have the formula here for us to look at. And this is the formula that we use. The probability of x equaling either 0, 1, 2, or 3 uses the combination formula NCX. N is the number of trials, x is the particular x value, either 0, 1, 2, or 3. P is the probability of a success, which we said was 1/6. Q is the probability of a failure. That's going to be 5/6 to the n minus x. And here we have the same formula with the combination portion of it written out. The combination formula is n factorial over n minus x factorial times x factorial. So since we need at least 2 ones, we need to calculate the probability of 2 successes, the probability of 3 successes, and then add those together. So let's calculate the probability of 2 successes. Probability that x equals 2 will be 3 trials with the combination formula for 2. P is 1/6 to the 2. Q, that's 5/6. And this is going to be to the n minus x, number of trials minus our x value. So this will be the first. And you can keep in mind that these two will always add up to be the number of trials that we have. So let's calculate that combination formula. We have 3 factorial over 3 minus 2 factorial times 2 factorial. 1/6 to the second power will be 1 over 36 times 5/6. 3 factorial, that's 3 times 2 times 1. 3 minus 2 is 1, and 1 factorial is 1. We have 2 factorial, which is 2. So that's 5 over 216. And we'll cancel out these 2's, so that gives 15 over 216. So then I need to find the probability of 3 successful trials. That's probability that x equals 3. So 3, choose 3. 1/6 to the third, 5/6 to the 0. That combination formula would be 3 factorial or 3 minus 3 factorial or 3 factorial times, let's see, 1/6 to the third power would be 1 over 216. 5/6 to the 0 power would be 1. And 3 factorial divided by 3 factorial is 1. 3 minus 3 factorial, that's 0 factorial, that's 1. So we have 1 over 216. We're going to add those two together. 15 over 216 plus 1 over 216 gives me 16 over 216. Let's reduce that. Let's see, I know that 4 goes into each of them. 4 goes into 16 4 times. Let's see, 4 goes into 216. "54 times." I can reduce that one more time by a factor of 2. 2 goes into 4 2 times. 2 goes into 54 27 times. So we get a probability of at least 2 ones being 27 over 2. So on question 3, we're going to let f of x equals cosine squared x. We're going to assume that u of x, that's u of 0 is pi over 4, and that u prime at 0 is 3. We want to determine the value of f composed with u prime at 0. So we want to find f composed with u prime, the derivative of f composed with u of x first. Now, when we have the composition of functions and we're calculating the derivative, we need to use the chain rule to do that calculation. So I'm really thinking of this as f of u of x and then calculating the derivative of that function. So I've got an outside function of f, an inside function of u. I'm going to follow that chain rule where I calculate the derivative on the outside function. I'm going to leave the inside function alone, and I need to chain by multiplying by the derivative of the inside. So now I have the format for the derivative, and I want to substitute 0 in for x. So I need f prime u of 0 times u prime at 0. I was given some of this information. I was given u of 0 to be pi over 4, so that's f prime of pi over 4. And I was given that u prime at 0 is 3. And I need to do a little bit more work here because I have f, but I don't have the derivative of f. So f of x is equal to cosine squared x. I'm going to think of this as cosine of x squared. I need to calculate the derivative using the chain rule. The outside function is my power. I bring that power down. Leave the inside alone, but I'm going to take one away from the power. So instead of that cosine being squared, it's to the first power. And then I have to chain by multiplying by the derivative of the inside. The derivative of cosine is negative sine x. So to find f prime at pi over 4, I need to do negative 2 cosine of pi over 4 times sine of pi over 4 times 3. That's negative 6. Cosine of pi over 4 is square root of 2 over 2. Sine of pi over 4 is square root of 2 over 2. So we've got negative 6 square root of 4 over 4. Square root of 4 is 2, so this is negative 12 over 4, and that's negative 3. So we've got negative 3 as our solution to this example. On number 4, we want to know which of the following is equal to sine of 3x. So we're looking for identities that we can manipulate sine of 3x with. So my first thought, since it's 3x instead of 2x, is to use one of our sum and difference formulas. I've got some of the formulas here. So I'm going to start with sine of 3x. Write that as sine of x plus 2x, so I can use the sum and difference formula. So I'll treat x like u, 2x like v, and that will give sine x cosine 2x plus cosine x sine 2x. And then I want to bring in the double angle identities and simplify cosine of 2x and sine of 2x. I'll be able to write sine x, the double angle for cosine. It's right here. And I'm not sure which one I should use. Let's try this one here. Cosine squared x minus sine squared x plus cosine x. We'll use the double angle identity for sine. So we have sine, 2 times 2 sine x cosine x. If I distribute, I'll have cosine squared x times sine x minus sine cubed x plus 2 sine x cosine squared x. And now I can combine these two like terms together, and that will give 3 sine x cosine squared x minus sine cubed x. And I believe that's one of the choices. Let's look back at those choices. We have answer choice B, 3 cosine squared sine minus sine cubed. On question 5, we want to find the sum of the following series. We have sum of n equals 2 to infinity of negative 1 to the n plus 2 to the 2 over 3 to the n. So when I initially look at what I'm trying to take the sum of, it doesn't look like one of my standard converging sequences like the geometric sequence. So what I'd like to do is to start to write out some of the terms of the sequence so I can see if there's a pattern. So if I let n equals 2, I'll have negative 1 squared plus 2 over 3 squared plus n equals 3, that's negative 1 cubed plus 2 over 3 cubed. Let's write out a few more terms and then we'll simplify to see if we see a pattern. So n being 4, negative 1 to the 4th plus 2 over 3 to the 4th plus negative 1 to the 5th plus 2 over 3 to the 5th plus negative 1 to the 6th plus 2 over 3 to the 6th. So let's see. And then we'll, of course, continue the sum to infinity. So we have negative 1 squared. That's a negative number to an even power. So we get a positive, and it's going to be a positive 1. 1 plus 2 is 3, so we have 3 over 3 squared for the first term. Negative 1 to the third, negative 1 to an odd power will be a negative 1. Negative 1 plus 2 is 1 over 3 cubed. And then we have negative 1 to the fourth power. That's positive 1 plus 2 is 3 over 3 to the fourth. Negative 1 to the fifth. That's negative 1 plus 2, which is 1 over 3 to the fifth. Negative 1 to the sixth will be 1 plus 2. That's 3 over 3 to the sixth. So if we simplify, we've got a common factor of 3 that we can cancel out here. That would give 1 over 3 plus 1 over 3 cubed plus 1 over 3 cubed plus 1 over 3 to the fifth plus 1 over 3 to the fifth, and so on. So it's looking like after the first term, we have pairs of terms that are like fractions, and we can combine them. So we'll get 1/3 plus 2 over 3 cubed, 2 over 3 to the fifth, and so on. Okay, so now I think I'm going to reform this as a different nth term than what I originally had. So that would be 2, let's see, let me back that up. I'm going to write this as the sum of 2 over 3, and these exponents are odd numbers, so I need to write an odd number. I'll write 2, and I also want to start my sequence at 0 so that I can use the geometric sum formula. So I need that to be 2n plus 3. So that's going to start, if I plug in a 0, that's going to start with an exponent of 3 and then go up by odd numbers. So this will go to infinity. So what I want to do now is a little bit of simplification so that I can write this in the format to use the geometric sum formula. So I want to get it in this format here. The sum n equals 0 to infinity of the first term times r to the n minus 1 is the first term over, I think I've got this wrong. This is r to the n. We have a over 1 minus r. So that is the sum of this infinite series. So I need to get the summation in this format on the interior, the first term times r to a power. So let's write this as 1/3 plus, and I'm going to apply this 3 and apply this 2 so I can get r to a power, the base 3 to a power. So the sum n equals 0 to infinity of 2 over 3 squared to the n times 3 to the 3. That's 1/3 plus the sum of n equals 0 to infinity. And now I have 2 over 9 to the n times 27. So I'll write this as 1/3 plus the sum n equals 0 to infinity, 2 over 27, 1/9 to the n power. So now I've got it written as the first term times r to the n, and I can find the sum of that infinite series using the formula. The first term, 1 over 27, over 1 minus 1/9. That's 1/3 plus 2 over 27 over 8/9. I'll multiply by the reciprocal. That's 1/3 plus 9 over 8 times 2 over 27. So 2 goes into 8 4 times, 9 goes into 27 3 times. So we've got 1/3 plus 1/12. We get a common denominator. So that's 4/12 plus 1/12 is 5/12. So we have our answer choice there, answer choice C for this one.